All right, today we are doing something called Piecewise Functions. Everybody say Piecewise Functions.
Piecewise Functions.
Got to be able to say it to do it. Okay. This is in the Big Ideas book, and we are doing page 222, 1 through 55 odd. So, a piecewise function is really just a piece of a function. It looks really scary, but in actuality, it's not as scary as you think, and you just got to learn to understand how to read it. So what this really means is, this is saying, first of all, let's talk about, we are using function notation. Function notation is where we use our input and our output at the same time to write the equation. So the f of x equals x plus 4. So for instance, let's say I wanted to know what happens when x is 2. Let's just say 2. The function of 2 is equal to 2 plus 4. So I'm able to use the input to discuss the output. Okay? The function of 2 as an input is equal to 6 as an output. Does that make sense? So that's just a quick review on our function notation. It's a way we write the equation. The f of x really is just the fancy way to write the y equals x plus 4. So if x is equal to 2, we said it was, 2 plus 4. Remember, we're saying the f of x equals x plus 4. The f of 2 equals 2 plus 4. The f of 2 is equal to 6. So y equals 6. Right? It's really the same thing. The f of x means y. It's just a fancy way to write where we're using the input to discuss the equation. So when it says to evaluate means find the value. Okay? Now, what they're doing is they're giving us specific domains. The domain is, what is x allowed to be? So they said evaluate when x equals 3. So if x equals 3, I have to look at my domains. And these are my domain restrictions. So which domain would x equals 3 fall into? Is it x is less than 4 or x is greater than or equal to 4?
X is less than 4.
So if that is the case, x is less than 4, then I go, if that is the domain they want us to use, it is that equation that I need to evaluate. So I'm doing the f of x equals x plus 4. How do I know to use that? Because it fits into this domain. So I go to this equation, and then I use the input, the f of 3 equals 3 plus 4, and the f of 3 is equal to 7. Does that make sense?
Mm-hmm. So you always have to look up the inequality first? Or?
It's not the inequality. Right now we're calling this a restriction. It's a restriction. It's a restriction of the domain. And the domain is your input. The domain is your x. What is x allowed to be? So the first thing they do when they give me a domain is I have to look at my restrictions and see which domain restriction does it fall under. It falls under this one. So that's why I'm using it. Let's look at the next one. Ready? When x is 5, which domain does it work with? This domain here? No, can't use it there. Does it work with the other one? So that is the equation that I'm going to be using. The f of x equals x minus 1. The f of, this time we're using 5, equals 5 minus 1. This would be a good time for you to start taking notes. The f of 5 is equal to 4. Okay? Okay, now we have another domain restriction. Another domain they're asking us about, which is -1. So which domain restriction does it fall under?
Less than 4.
Less than 4, this one right here. So I use this equation, the f of x equals x plus 4. The f of the input -1 equals -1 plus 4. The function of -1 as an input is equal to 3. And when you write your names, you always want to tie it to the input. Does that make sense? Okay, questions? Is everybody clear on evaluating?
Yes.
Okay, that's the first part of piecewise functions. Okay, now they're going to ask us to graph. Can I move on? Are we good? Now they're going to ask us to graph the piecewise function. When graphing the piecewise function, we've got two functions that we're graphing. So let's take the first one. The f of x, let's just go y equals x plus 4. What's my m? You should be writing this as we're going, okay? My m is what? 1. What is my b? 4. Okay, so I'm starting at 1. And then, no, I'm starting at 4. Right? 1, 2, 3, 4. And then can you see my in that purple?
Yeah, I do.
That purple is so bad. It's blinding. Okay. Yeah, kind of. I'm gonna pause it. All right, so here we go. I'm going to draw the line. I used yellow to change the color. Let's see. And now I'm going to draw my line. It's an equation, so it's not solid or dashed. It's just a solid line because it's an equation. Now, I wonder if black would be better. What do you see best? Yellow?
Yeah.
Okay. So there's the line. Now I have to take into consideration my domain. And that was the first equation. The domain has a special restriction here. Okay? The domain says x, I only want to see where x is less than 4. So this is like a number line right here, right? This is 0, 1, 2, 3, 4. Here's -1, -2, -3. So they only want to see from -4 on. So I follow that point up, and I'm going to make an open circle. Okay? An open circle at -4 and come all the way up. Do you guys understand? Now, why would I do an open circle?
Because it's just x is greater than 4 instead of x is greater than or equal to 4.
Right. X is greater than 4. So do you see how I just erased everything that goes in this direction?
How come?
Because the restriction says I only want to see the equation for any x that is less than 4. Here's 4 on my number line, right? My 4 is right here. So I'm going to follow that up. Anything past this boundary line, I don't want to see anything on this side. Do you understand? That's what the restriction means. I only want to see x's that are less than 4 for this equation. Okay? Now we're going to draw the next one. I think I better go black. You guys with me? Now for the next one, it says y, or the f of x, equals x minus 1. What's my m?
Sorry,
1. What's my b? Should we go blue? Let's try blue maybe. Okay, so I'm starting where, Nicole? at -1 right here. And then I'm going to go, right, so it's going to kind of go here, parallel. Right, and I'm just making little dots so I can make my line. Okay, so now I'm going to go. Okay, now this one says what? What is the restriction?
Greater than or equal.
I only want to see x greater than 4. So from this same boundary line on, here's the boundary, here's 4. So only numbers greater than to the right. Everything to the left of that boundary line, I'm going to erase. Does that make sense? And so, I'm going to do is it open or a solid circle?
Solid.
It's solid because x is greater than or equal to 4. Does that make sense? You graph it like normal, then you use your restriction to erase the part they don't want you to see. And so this is what we call a piecewise function. We've just graphed a piecewise function. Yes, I'm understanding. No, I'm not. Okay. Oh my gosh, here, hold on, let's pause it. So one more time, we're graphing the two equations like normal, and then we erase the part so it satisfies the restriction of the domain. Okay? Can I erase it? Okay, so let's see what they're doing. They used red. Oops. Okay. Now, this is what we would call a step function. How do you graph a step function? And it's called a step function because it looks like steps. Okay? So really, remember, our f of x is really like our y. So this is a number of equations, right? Y equals 1, y equals 2, y equals 3, and y equals 4. Are you with me? On the first part, they only want, now they're going to show you, I only want to see it from 0 through 3. So I go to the 1, right? And what kind of line is y equals 1?
Dash.
No, whatever you have y equals a number on a chord, it's a horizontal line. So it's going to be, I go up to 1 on the y-axis, and it's just going to be, I'm going to be this horizontal line, right? Let me go like this. Okay, so we go to 1. I got a better idea. Let's make the size thicker. There we go. Right? Isn't that better? There we go. Much better. Okay, so there it is. But they only want you to see it on the x-axis, the domain from 0. This is like a number line. 0, 1, 2, 3, 4. You with me? So they only want you to see it from 0 to 3. So I erase all of this, and I go up to 3. Now, the bottom one, this point is filled in. But this one at 3 is open because it says it doesn't include 3. Now, the next one is 2. So I'm going to 2. Really, my line should be somewhere in here. But they only want from where? The 2 one, they want you to go from 3 to 6. So I'm going to erase 1, 2, 3. And I'm going to, is that solid or is it closed?
Solid.
Solid. And I go to 6. 4, 5, 6. Is 6 open or solid? You get the idea? And then the third one is y equals 3. But 3, that would be the next line up. They only want you to show from 6. And we're going to go to 6, 7, 8, 9. And this one, oops, I'm going to erase it a little, right? Should be an open circle. Right? And then the last one is 4. 4. So I'm here, and they're going starting here. And we're going to go, this is going to be hard. 5, 6, 7, about that same amount, and up to 12. Does that make sense? So see how it looks like steps? That's why it's called a step function. A step function is a kind of piecewise function. All right, how do you guys feel about this one?
Good.
Yeah? I didn't get to explain that today. Okay. So we're basically doing the same thing. These are all y equals. Okay, write an equation for this piecewise function. So now we're going to write the equation. Whoops. Okay? You guys with me? Everybody's going to write it. Okay, so the first one is, we're going to make this giant brace. And let's look at the first one. What is y equal to here? 1. And the restriction, comma, it's an in-between statement. It goes from what? Negative
6 to negative 4.
negative 6 is less than x, which is less than or equal to 4. The next one, 2. What would it be? Negative 4 is less than, which is less than.
Wait, where's 2?
What? 2? Okay. What's your question? Hold on.
Negative.
What's your question?
Isn't it negative?
Yeah, negative 2. Oh, but no. Because when we say 2 here, this 2 means it's the line that's going through this equation, right? X, Y, 2, 2, 2, 0, 1, 2. So it's this line, right? It's this line that goes through here. What I mean by 2, it's going through positive 2 on the y-axis, right? This is going through positive 1, on the x-axis, right? That's different than the other negative going to the left, okay? So the next one, Nicole, where would what would I write for the next line right here? Right, it's 3, and it goes negative 2.
Less than x, which is less than or greater to 2. I mean,
No.
3.
Now, when you're doing the restriction, you're talking about the x-axis number line. Okay, this is negative 2, and it ends here. Where?
Oh, on 0.
0. Okay, 4, right? The next one is 4. What's the boundary for that?
It's 4.
This one, that's what I write for 4. We're talking about this line right here. But what's the boundary? You got to look to the x-axis down
0.
below. 0. Keep going.
Is less than x, which is less than or equal to 2.
Good. Next one. This one right here.
5 is
Where? What's the boundary of the domain?
2.
2.
Is less than x, which is less than or equal to 4.
Good. You get the idea?
Mm-hmm.
So that's how we write the step function. Okay. Let's go to the actual book work. Greatest integer function. Okay, so in your book, tonight we're working out of, when we see this, this really is just talking about two equations. The f of x, it's like saying the f of x equals x minus 2 and the f of x equals 2x plus 1. How do I know if I'm evaluating? We use either right here, this goes with this, and this restriction goes with this. So if they gave me a domain of like 5, which equation would I use?
If x is greater than 0?
Yes, we would use the second one. If they gave you a domain of -5, we'd use the top domain equation. Okay? So the first part was evaluating. So when x, and they said when x equals 0, which one would I use? X is less than or equal to 0, so that means I would use the f of x equals x minus 2. So I do the f of 0 equals 0 minus 2, so the f of 0 is equal to what? Negative 2. And for the next one, we're doing the f of x equals what? Which am I using when x equals 4?
2x plus 1.
2x plus 1. How did we know to use 2x plus 1? Brianne?
Because 4 is greater than 0.
Because it fits the domain for x is greater than 0. And that goes with this equation. Do you understand? So now we're doing the f of 4 equals 2 times 4 plus 1. The f of 4 equals 9. Questions? All right, moving on. So now when they give us all these kinds of like 1 through 6 here, which function would I use for number 1? Which domain does it fit in? Domain restriction does it fit in? Julia, does it fit in the first one, the second one, or the third domain restriction?
It fits in the
First one. So I'm writing the f of x equals 3. So when I write the f of negative 8 equals 3.
Wonder where did the second one fit?
Yeah, it would fit in the second one, not the
No, because it's in between negative 2 and 5.
Yeah,
It's not greater than
yeah, 3 is in between.
No, you're looking at the domain. Where does the domain, you have to fit it into the, you choose the equation based on the domain restriction.
Looking at the wrong thing.
Does that make sense? Now, really, what kind of line is this when it says the f of x equals 3?
That's a straight. That's a
horizontal.
Horizontal line, that's a y equals 3. So no matter what, it's always going to be 3. Whether it's 0, 1, 2, or negative 8, it's still going to be 3. Do you understand? Is that making sense? Now, the next one. Which domain does the f of 0 fit into? Jamie?
x plus 2.
X plus 2. So 0 is between negative 5, and so that would be the f of 0 equals, I'm going to use the f of x first. F of x equals x plus 2 because it fits in that second domain, so the f of 0 equals 0 plus 2. Okay, I want you guys to finish the rest of these. Pause the recording and tell me where you're at. All right, so on number 2, I'm doing the f of x. Where does that fit? Which domain? X plus 2 because it's between negative 2. So I'm doing the f of x equals x plus 2. So the f of negative 2 equals negative 2 plus 2. So the f of negative 2 equals 0. And you should be writing these down right here next to them. So the first one we got 3. The number 3 we got 2. This next one we get 0. What about the f of 5? Also works for the second one, right? 5 plus 2, so the f of 5 equals 7. And then the next one, the f of 3, where does that fit? Same one. 3 plus 2, so the f of 3 equals 5. And then the f of 10 falls into which one? 4x, so the f of 10 equals 40. You get the idea? All right. We talked about graphing. Everybody understands how to graph? We graph the equation and erase the part they don't want us to see. We only show the part that the restriction asks us to show. Okay? And in this case, if they want us to describe the domain, if this were the picture, right? Is that in this function, if they want me to describe the domain and range, in terms of the x values, doesn't it pick up every positive x in this direction?
Yeah.
Yes? And it includes the 0. And in this direction, this picks up all the other x's. So isn't that mean that for the domain, all real numbers are picked up for this piecewise function? For either one function or the other? Do you understand what they're saying? In terms of the range, that's how high. It picks up, the range might be a little bit different. Whoops. Right? The range is how high. This, okay, this picks up all numbers from here all the way on. So for the range, the y is greater than what number? -4. Does that make sense? But for the domain, it's all real numbers. For this piecewise function. Does that make sense? Okay, let's see what else we got. Write the piecewise function. Did I show you how to write the, okay, so this is the last part. How do we write the function for it? What's your m, what's your b for the first line? M equals, b equals. So my b is what? 3, and my m is 1. So y equals x plus 3. But I'm going to write it, the f of x equals, we're going to put x plus 3, but now we have to write our restriction, comma, where x, what? What x's am I using for this line? Is less than, on the x-axis, 0. X is less than 0. Now the other equation, what's my m and what's my b? Hold on. -1. Okay. And it's 2, right? And so it's 2x, where the restriction, x is greater than or equal to 0. Hold on one second. What? Because we're only picking up these x's here from the 0 point on, right? You never see this line on anything else over here. Okay, now the step function. That is usually, I want to talk about like a word problem. Hold on. I want to talk about a word problem. This is perfect for like renting things. Like they have the karaoke machine. The rental company charges for $50 for the first day and $25 for each additional day. So do you understand what from day 0, even half a day, up to day 1 and including day 1, you pay $50. But a minute past day 1, you pay what? $75. A minute past 2 days, you pay the $100. Other types of word problems that work with this are like parking garages, right? You might have like a base charge of, $2 and $1 for every 20 minutes. Do you understand? From minute 1 to 20, it's $2 and $1 plus 1 from, up to 40 minutes. Does that make sense? So I barely got time to talk about these, but I think you understand the word problem. So, okay, that's the